Hello everyone, let's walk through this math challenge on the board. If A, B, C are the pth, qth and rth terms of an AP, that is arithmetic progression, our task is to prove that this expression is equals to 0. So what I will do first is to write ABC using the nth term formula for an AP, and that is, we know that the nth term formula for an AP is T subscript n equals to A plus parenthesis n minus 1 D, where D is a common difference, n is the number of terms, and A is the first term. Alright, so in this case, I'm going to choose a different letter, okay, to represent the first term, because pth, qth and rth term will have the same first term, only that ABC will be used to represent pth, qth and rth, okay, in the formula, okay, respectively. So it means that for pth term, let's say for pth term, we're going to have lowercase letter a, okay, to be equals to, let me use higher case letter a as the first term, plus p minus 1 times d, okay, that's for pth term. Then also for qth term, it will be b equals to higher case letter a, parenthesis, q minus 1 multiplied by d, which is a common difference. Then also for the rth term, we're going to have c to be equals to higher case letter a, parenthesis, r minus 1 multiplied by d, which is the common difference. So what to do next is, now I'm going to obtain the expression for b minus c. Okay, so whatever I get as the expression for b minus c, I'm going to multiply that by p. And I'll do the same with c minus a multiplied by q, parenthesis a minus b multiplied by r. All right, so for b minus c, okay, we can see from here that this is b and it equals to higher case letter a plus parenthesis q minus 1 times d. Then we have lowercase letter c to be equals to higher case letter a plus parenthesis r minus 1 times d. So b minus c will be a minus a, that will be 0. So here we have parenthesis q minus 1 times d minus parenthesis r minus 1 multiplied by d. So now let me remove the parenthesis. So in this case, we're going to have qd minus d, then minus dr plus d, negative d plus d, that will be 0. So in this case, we have qd minus dr, which will be q parenthesis q minus d minus r, okay, multiplied by d. So now when we multiply b minus c by p, that is the expression for, to obtain the expression for p parenthesis b minus c, then we're going to have pd parenthesis q minus r. Okay, now also I'm going to obtain the expression for c minus a first, and whatever I get, I'll multiply it by q, and I'll do the same with parenthesis a minus b times r. All right, so for c minus a, so here we have c and then we have a, so a minus a, that will be 0. So we have parenthesis r minus 1 d minus parenthesis p minus 1 d. Okay, now removing the parenthesis, we're going to have dr minus d minus dp plus d. This will be 0. So from here, we're going to have dr minus dp, which will be r minus p, parenthesis r minus p multiplied by d. So when multiplied by q, okay, q multiplied by c minus a, that will be equals to, we have q times what we have here, that will be qd parenthesis r minus p. Okay, now to obtain the expression for this, so first we need a minus b. A minus b, that is a minus a, that will be 0. Then subtract this from this. So we're going to have parenthesis p minus 1 d then minus parenthesis q minus 1d. So that this will be pd minus d, okay, minus qd plus d. This will be 0. So that this will be pd minus qd. So that p parenthesis p minus q multiplied by d becomes the expression for a minus b. Now, so what you do next is to multiply whatever we get by r, which will be equals to r parenthesis a minus b. So the expression for r parenthesis a minus b will be when we multiply this by r. So this will be equals to r parenthesis, or we have rd parenthesis p minus q. Okay, so now I'm going to add this, okay, because we have r parenthesis a minus b, and also add this, which is what we have, which is the expression for q parenthesis c minus a. And I'll also add this. I'll add the three together, okay? Now, by adding the three expressions, are we going to get 0? Okay, that's what the question is all about. So for the first one, p parenthesis b minus c, we got pd, okay, parenthesis q minus r, then plus the second expression is qd parenthesis r minus p, then plus rd parenthesis p minus q. So now I'm going to remove the parenthesis and then simplify. Okay. All right. So we have, this will be pdq minus pdr plus qdr minus pdq, then plus pdr minus qdr. Okay, so we have pdq minus pdq to be 0. Negative pdr plus pdr is 0. qdr minus qdr, that's also what? 0. And this is how to prove that this expression is equals to 0. The noblest pleasure is the joy of understanding. Bye-bye.